Hello everyone. Let's go through object-oriented programming in JavaScript. So in a previous video, we went over objects, basic JavaScript objects and why we use them. So if you didn't watch that video, maybe go back and watch that so we can establish our basis of why we use objects at all. Now we're going to talk about why do we use object-oriented programming, some of the parts of OOP and why they are the way they are. And maybe I'm going to go through the evolution of how you go from using plain objects to OOP. Maybe that will help your understanding of why we have certain things like the keyword this. So if we started off and we were deciding to build an app, and say we wanted to build a survey app that took the survey of people living in a city. And the objects that we decided were in our app were people. And so we simply just had a bunch of objects, maybe that looked like this: name, age, zip code. And we made one and put it into a variable person. And we made another one and put it into a variable person2. These are just plain old objects. And maybe I might say, for some reason, I want to print out the person's name. So I'm going to create a function for this so that it can do the work for me. So I have a reusable function to print out a person's name. The code for this is going to expect that whatever is sent in as a parameter is a person object. And it's going to expect that that person object that you send in has a name property. So it's expecting send in a person object, and we'll console log out the name property. So the first thing we can see is that these are totally separate. This function has nothing to do with these objects. They're totally independent things. We might also notice that, well, let's give an example of calling this function. So if I call this function, I might send in person1 or person. And this is good, this is fine. But if we really think about it, because this function is just totally separate, JavaScript allows us to send in anything we want into the function. So we don't have to send a person object. We can send anything: a number, a string, an array, whatever. So if we sent in the number 1, it would still work. And so what would happen if we did this? Well, if you might have guessed, it's going to print out John for the person, but it's going to print out undefined for 1 because the number 1 does not have a name property. So we might notice that, that's not ideal. It's not exactly what we want. And then we might say, well, another thing might happen. What if we do pass in a person? So let's send in our person2. But for whatever reason, something got messed up and the coder or something forgot to put the name property on it. So what would you think would happen with that? So let's run that. And as you might imagine, the same thing happens as passing in 1. Person2 doesn't have a name property, so it just prints out undefined. Okay, so that's not really what we want to have happen. We're kind of seeing some issues here. Nothing is regulating what you put into this function. So we've observed 2 potential issues here. An object is not guaranteed to have a property that it should have, maybe, and functions cannot be controlled, or you cannot control what's sent into a function. So what do we do about this? Well, we might think, how about we make a function that controls how objects are made. And we might call this a factory function or a constructor function. In OOP, we might call it a class function. This is the first exposure to why we might want to use OOP and these concepts. So let's just create this function that we are going to call its person. And this function is going to be responsible for making person objects. So we will say, I'll just make this function. And since it's just a normal function, I'm going to call it. And whatever is returned from the function, we'll just put into a variable representing a person object. Well, we can see that obviously there's nothing in this function. It's not returning anything, so nothing's going to be in here. So let's fill in the blanks of what we need to do. So we think, okay, what is the point of this function in the first place? As we described, it's to make objects, to control the construction of objects. So, well, if we're making objects, then let's make an object. And we'll put it into a variable called me. And then we say, well, the point of this is to control what the object has. We say that an object has to have a name, or a person object has to have a name. It has to have an age, and it has to have a zip code. We've defined that that's what it must have. So let's put that in there. And then, because this function should return that out and give calling code an object, let's return it. So say, okay, in order to make a person object, you no longer should do it manually or through object literals yourself. In order to make a person object, you should call the person constructor function. Okay, so that we've established that. That's just a kind of a rule that we must do in our code in order to create person objects. Now, technically, of course, this is not enforceable. We can't force people to use this, but it makes things a little bit better than they were. Okay? Okay, so if we look at this, we might say, well, let me run this and see what happens. So if I make person 3 and a person 4, and I run this code, I'm going to see what comes out of these people. So person 3 has age 33 John zip code. And then we're going to see person 4. Person 4 also has the same information. And so we successfully created person objects. In the debugger, you can see it says object. So we've made these objects with the properties that we need. But you might obviously see that this is not very helpful because we've hard-coded it to John and 33. And this is going to be the same information every time. So we need to make this dynamic. We need to make this changeable. And because our constructor function is just a function, we know that functions can take in parameters. And so we could say, well, every person's going to be different. So we need you to be able to send in what the person's name is, the person's age is, and the person's zip code is. Those are just normal parameters like always, and we can use them to assign to our objects properties. So name, P age, I just put P for person so that it doesn't confuse with the property name. Okay, and so when we change the function to accept parameters, we then of course have to send in arguments. And we can now send in different arguments to make the objects have different information, which is realistic. That's exactly what we want. People don't all have the same names and age and zip codes. So now if we debug, I look at this one, object John, and person 4 is Dan. So looks good. Okay, cool. So we have our constructor function controlling the creation or the construction of person objects. You may still be a little hesitant into how this function is any better than making these objects directly. Well, one thing that it allows us to do is, since it's controlling the construction of the object, we can now enforce that the information we want is provided. So we could say, every person has to have a name. If you don't have a name, that's not a valid person. Maybe. So we could say, we can check whether there is a name provided. Otherwise, we could console log an error. Now, this is a trivial example. You could do something more serious here, but this is just demonstrating that now, when you're creating the object literals, you can just create them and just put whatever you want or forget to put whatever you want. But if you're using a constructor factory, it can control the creation of the object, and you can check for certain things. Okay, so that's another aspect of it that helps us. And along with that, when we look at this function, we can clearly see that what properties are expected to be in a person. So it's like an actual physical blueprint. So sometimes classes or constructor functions are compared to blueprints. And then when you actually make an object, that's like actually building the house. So we have our blueprint and then actually building something from the blueprint. Well, that helps us out because we can read the blueprint. We can see exactly what a person object is supposed to have. Whereas if you're just making person objects on the fly, you have no idea that, or you may have no idea that somewhere there is this person, print person name function. Maybe this was way down here, not next to each other. You have no idea that this print person name function requires a person to have a name. And so you just forgot to put a name, even though that kind of doesn't make sense, but just for our demo purposes. Okay, so this is that is why we build these classes or constructor functions. Okay, so there is one more thing about that, and that is when we create this object and return it out, JavaScript kind of wants to help us with that. So it says, we're not going to make you code this part. You don't need to do this. We'll do it for you. And the only thing you have to do in order to have JavaScript do this for you is that when you call the constructor function, you put the new keyword in front of it. So when we use this keyword in front of the function call, all of a sudden it magically does this and this for us. Just a few little lines of code that we no longer have to write. Every bit helps, right? Okay. And there's one more thing to finish this out. JavaScript doesn't call the variable this, or me, sorry. It calls it this. Okay. So now we've completed our class, our person class or constructor function. So now, what was the whole point of this? Let's think back and remember our print person's name function. So The whole point of this was to say, if we're going to print someone's name from a person, then that person better actually have a name. And because we're using the class now, the person class, we know we've ensured that these objects do have a name. So when we run it, clear that out. And we print person 3 and person 4. And we can see it logs out John and Dan. So now we've solved the problem of ensuring that objects have properties that are expected of them. Okay, but we still have our other problem. Nothing is controlling what gets sent into the print person's name function. I can still send in whatever I want, and it will make unexpected behavior occur. So how do we deal with this? How can you possibly control what's sent into a function and say, no, you can only send this thing into this function? Well, we can handle that. So if we're saying that print person name function should only work with a person object, it should only accept a person object as an argument. If we're defining that, then the goal is to not let other code decide what's being sent into the function, because other code can just send whatever it wants. We have to make it so somehow this print person names function only takes a person object. And the way we do that is by making the function a method of the person class. So if we are saying this function should only work with the person object, then we can put the function in the person class to establish that, to make that so. So how do we do that? Well, we say this function should only work with person objects, so we are going to make it a method of a person object. Now, because we know it only works with person objects, we probably don't have to say print person's name anymore. We just want to say print person. And we'll do the same behavior, and we'll get rid of this. Okay, so when we have a property with a function in it, that's called a method. That's just the terminology. We now call it a method. And this method is only allowed to operate with person objects. That is what we're defining. So if we now run this, we might notice something, some problem or some issue that's going to happen. We see an error. Print person name is not defined. Well, what happened? Well, we took the function away that was globally accessible and we put it inside of this object. So what that means is this function is only available off of an object. So what does that mean? Well, it means first you have to have an object, which we do, person 3, and now you do the dot notation to access that property. Because that property is a method or a function, you call it. Okay? So we need to remember the syntax. When there is a method defined in a class, you first have to have an instance of that object by doing this, and then you do dot whatever the method name is to call it with parentheses. Okay? So that's fine. So we can get rid of this, but we still have a problem. Can you see the problem? This function is still taking a person argument, person parameter. So nothing even though we're now calling it off of the person object, we still can send in whatever we want. If I send in 1, I can still do that. And the method will just be called as normal. And of course, we get undefined because 1 does not have a name on it. So now what do we do? Well, we said somehow we're leading up to controlling what's sent in. And so we can just, let's control that. We're not going to let you send in anything. So that's fine. But now if we run it, you might see that something is probably not going to go right. And we see an error. Person is not defined because we took away the person parameter or the person variable. So now you're trying to use it, console log it out, but it's not there. So of course an error happens. So what do we do about this? Okay, so we need to, this is where it gets a little tricky, but because this is a method off of a class or off of the person object, JavaScript is going to magically send in the person object into this function automatically in an invisible variable. And can you guess what the name is of that invisible variable? Is it called person? No. Is it called me? No. Well, hopefully you guessed it. It's called this. So there is a invisible variable here called this. It's there because this function is a method. So where we had person before, we say, nope, we don't need that anymore because JavaScript is automatically sending this in. And we just, wherever we use person, we now need to change it to this. This variable is going to contain whatever object you called the method off of. What does that mean? Well, right here, this is what we're doing. We're calling the method off of person3 object. So in this case, this is going to be whatever's in person3. So let me run that. So if we go into the print name function, we can see there's no argument here. There's nothing. But if we hover over person3, oh, well, let me go back and look at person3 first. We can see it is a person with the age, name, and zip code. It's John. And when we call the method off of person3 object, it just goes into the function like normal. And if we look at this, this is the same as person3. It's a person, age 22, John. So it is the same thing. It's very important to understand the concept that whenever you call the method, this is the object you call it off of. So if we did person4, name, and as you could see, I sent in 1, but it didn't matter. It just ignored that. It didn't care because it controlled the passing in of the parameter of the person object. So let's run this again. So person3 is John, person4 is Dan. And when I go in to the call of print name off of person3, this is still John. And then if I go into the call of person4, or print name off of person4, this is Dan. Okay. So if that's kind of not making sense, run through this over and over, and you'll get it eventually. So we have solved our second problem. Because we made a method, the JavaScript now controls what gets sent into the method as always being a person object, because that's the only way you can call this method. Print name, you can't call it by itself. You first must have a person, an instance of a person object, and then you call the method off of it, which ensures that what gets sent into the print name method is the person that you're using. So now we've used the JavaScript capabilities to fix our second issue of not allowing just any old random thing to be sent in to our method or our function, our print name function. Okay, so I think that's it for that. Now we just needed to cover one more thing, which is we still have one slight problem. It's very little, if you can think of it. So when people look through our code, how do they know that this function is a constructor function or a class? And I think we discussed that, and we said, well, the only reason is through the semantics, through this naming convention of putting a capital letter of the first letter in the name of the function. So we could have put a lowercase p, that would have been totally fine, but it's convention to put a capital P. Well, that's not ideal. We don't want to rely on human beings having to put capital letters in order to make sure our code runs properly. So we looked at how the new version of JavaScript, ES6, fixed that. So how do we do that? Well, now we actually have a syntax change that forces you to actually say, or to explicitly say, that something is a class. So all we have to do is change our function keyword to a class keyword. And now we can clearly see that this is a class. And instead of putting the code directly in the body of a function, we have to add a special method keyword called constructor. So we've used that word, that terminology, constructor, a bunch. So now we're explicitly using that in the syntax. So we changed the keyword function to class. We got rid of the argument, the parameter list next to person, and we moved it down here into our constructor method. And all of the code that was directly in the function is now in the constructor method. Okay, that is all you have to change. And so if I run that, we should see that it works exactly the same. So I look at person3, it's still a person John. Person4 is still Dan. And when I print out the names, it still prints out the name John and Dan. Everything else is the same. It's just the slight syntax difference so that we know, yes, this is a class. It is a person class. This is the constructor. This is how you construct a person object. You need a name, you need an age, and you need a zip code. And then everything else can be the same. Okay, I think that's it. Hope that helped a little. Thanks for watching.